Good afternoon, and I hope you're well. Sorry again for the background noise, but again it's the fans running in this room. I've got here a doorbell today, and this doorbell doesn't seem to work, so I'll show you what it does. Or should I rather say what it doesn't do. So this is the bell. When you click it, the light lights up, but there is no sound. Now there is one clue what's going on here. If I unplug it and plug it back in again, and then plug it back in, it makes half an attempt to make a chiming sound. So when you plug it in, it's meant to make a full chime. So I'm wondering if it's something to do with the actual supply inside the bell side of things. So like I say, my initial suspicion is that this bit is fine, because when you plug this in, we get half a chime and no more. So this would indicate to me that there's not enough power to do a full chime. Now I haven't taken this apart yet, but it looks like it's got some security screws, so I'll take it apart and we'll have a look inside. So this is inside the unit. You've got the speaker there, and in here you've got what looks like mains in, capacitive dropper, probably a inrush resistor, smoothing going on, and then you've got your antenna up here with a, how many megs is that? Oh, wrong way around. Oh no, it was the right way around. Oh, I'm doing this all wrong. Is that a 13 meg resistor? Crystal. So yeah, I think we need to have a measure. So I'll take that board out first. So by looking at the circuit, we've got the mains coming in here. Then we've got a passive dropper across this point where it's rectified. So we've got these are your diodes for a bridge rectifier, and you've got the output of this here and here, and then you've got a 25 volt cap across here. So then you also have a Zener, which is here, being bridged across by the zero link resistor. That must be capping this voltage to 25 volts, probably less than that. And then probably this is a voltage regulator for all the micros and stuff. So what I think we should do is put a probe across that cap, see if it's charging up, see if it holds charge when we ring the bell. So to make this a little bit safer, I've soldered on some flying leads here onto that cap, because this is a capacitive dropper circuit. All of this will become effectively lives at mains voltage, so you don't want to touch any of it. So I can put a scope probe on these and or a meter across this and see what it's charging up to. Right, so this is power's been applied, so we've got this plugged in here, the flying leads, and a DBM on the flying leads over that cap. That's the cap that comes straight from the capacitive dropper, and this charge should be the supply for the whole unit. If you look at it, the voltage is only 3 volts, and so that's probably why I reckon it's not working. Is there any AC component to that? No, there's no AC component, but we've only got 3 volts. I reckon, bear in mind this is a 25 volt cap, it should be at least 5, 6, 7 volts on there. So either something's pulling it down, or the capacitor has gone in the dropper. And that's quite common. The film in the capacitor tends to go. So I've got the meter now on capacitance, measuring across that mains input capacitor, and we're reading 0.24 microfarads. And if you can see that, the actual rating of the cap is meant to be a 0.47 microfarad cap. So what I'm going to do is remove that capacitor, measure it out of circuit, and see if it has actually lost some capacitance. Because we suspect the input cap has gone, dropper capacitor has gone, we could actually put some power on these two lines because they're across the main filter cap, and supply it with power that way. So we put, say, 5 volts, 6 volts, 7 volts on that line, we see if it powers up then. So we'll try it with 7 volts first, and a current limit of 100 milliamps. And they go to these leads, and I'll plug them into the doorbell. That's connected, so I'll just flick the switch on the power supply and turn it on. And that's the first chime, which is meant to do a continuous chime, and then we push the button. Right, that seems to work. So it does seem to be that dropper capacitor. So I'll see if I can find a replacement one of them. The only replacement one I have is a 0.33 microfarad. It is a tad smaller than the original, but the pin spacing's the same. I'm just hoping a 33 will work when this is meant to be a 47. But then again, it has dropped down to about 2.2, so it might work. And with that capacitor removed, it is reading 0.24 microfarads on the meter. Remember, it's meant to be 0.47, so it's dropped quite a bit. And I'll just check the new capacitor I'm going to put in there now. So this is the new capacitor I'm going to put in. I'm afraid it's the only mains rated cap I've got. So it's a 0.32, so it's a 0.33 rated cap. So we just have to hope that it's enough to actually make it work, but one way to find out. So the new cap is now soldered in, so let's plug it in and see if it works. So it's plugged in and it did chime and it does work. But there is still a bit of an issue because you can hear at the end it's starting to run out of power, so you can hear the sound fluctuating. So I don't think 0.33 is enough. Looks like I might have to order a 0.47. But for now it works and it will probably be good enough for now until I can order a cap. So yeah, we'll give that a go for now, and then I'll get a cap and change it in a later date. But thank you for now, and stay safe and see you next time.